seats up in front if you'd like to come up. We do have some open seats here. Moving on to our final presentation. This is on integrating programmatic and structural strategies for the Busan Lotte Tower. And for our presentation today, we have Brant Coletta. He is Managing Director with Skidmore, Owings & Merrill, located in New York. And he's completed projects in North America, South America, Europe, and Asia. And he's currently managing the eco-sensitive landmark super tower here in Seoul, and also the Busan Lotte super tower in Busan. With him is Charles Besjak, who is Director of Structural Engineering for Skidmore, Owings & Merrill. And Charles has been involved in many of Skidmore's tallest building projects, including the Lotte super tower here in Seoul and the Nanjing Greenland Financial Center in China. He lectures frequently on different topics, including high-rise design in seismic zones and unique composite structural systems for high-rise building design. Please welcome Brant and Charles.
Thank you very much. I'd like to start by saying this is a study of the form and structural integration as it relates to the program and the site constraints for the Busan Tower for Lotte. It's a Lotte Busan Town project that's located on the harbor in Busan in southern Korea. It's a little bit of the site context. You can see an overview of the city. Lotte came to us with this project with a vision that they shared with the city of Busan, which was to revitalize the historic downtown of Busan with a new retail and commercial development. This is the site itself. As you can see, waterfront reclaimed land that Lotte had spent at the time we became involved in the project several years building phase 1, which was a retail development. Again, site of overall Lotte. This is the old fish market, Yongdo Bridge, historic bridge in Busan, and the international ferry terminal, which I believe has connections to China and is envisioned as a major transit for China as well as other Asian countries. The site itself presented its own challenges, similar to what you heard in the last presentation, where this is a waterfront area. This is all reclaimed land. So the plan was to create a cofferdam system, which created a very tight footprint for SOM to design the building. And the other site constraint was in the location I'm highlighting here was an already under construction retail podium, phase 1 of an overall retail complex. So our site location in trying to fit this large program and tower on the site was very challenging. We had an overall program, large retail, office, condominium, and hotel, which we selected the site adjacent to the water, as I showed you before. The city had another constraint on the site, which was to allow pedestrian access to pass through the site on a very specific and rigorous location to connect the mainland area to the waterfront and waterfront park. The existing retail hub in the original master plan had a focal point, a rotunda, which was also under construction at the time we became involved in the project, which its relation to how we stacked the program on the site became very influential. And then lastly, the views of the harbor, in particular, the primary views which the client had insisted on maintaining or focusing on, were out in this direction. The hillside and the mountains were to the north. We came up with a triangular configuration to maximize the views out of the condominium units and the office units, and create a straight face that related to the retail podium that was already under construction. The main entrances became also a challenge, and again, these are very generic sketch ideas that we had at the very beginning of the project. The retail entrance, obviously, through what was already under construction, and then integrating a office, condominium, and hotel entrance on the remaining areas of the site. There wasn't a lot of space left, so it was very challenging to be able to organize those in such a way to give discrete and dedicated entrances. You can start to see behind these icons here, the footprint of the tower. was, again, a triangular configuration, extruded up directly as a straight extrusion was the initial thought behind the project, to keep a consistent construction sequence and constructability in mind. We then shaped the tower to maximize the views and give articulation to the exterior, which resulted in the shape you see here. We then studied how structurally locating mega columns at the exterior, which Mr. Besjak will get into in a second, were the main resistance for the building as it resisted torsion for the site. Again, we began to sculpt the building in relation to the program, which I'll get to in a second. And this is a view from the north looking out to the harbor of the building, on the mass of the building on the site, and a view with the ultimate final design of the building. This is the retail podium. This was the phase one that was completed about the time that we were becoming involved in the project. This is planned phase two, which is under construction now, and then the tower footprint location, which is also under construction. As I mentioned before, we had a cofferdam configuration here that was, we had a site constraint, which located our tower in one very specific location. So, squeezing this in and achieving 510 meters in height resulted in, as Chuck will mention in a moment, a very difficult slenderness ratio for the building. The floor plate itself transitions from a full build-out on the lower levels through the office floors as they start to set back slightly into the condominium and hotel floors, which require less of a lease span and less of a depth, core to glass depth. And then ultimately at the top, as with all of the super tall buildings planned around the world, a large observation deck. In studying the floor plate and the site constraints, as I mentioned before, we located maximizing the structure at the perimeter in the corners, and then began to carve back the floor plates, as you see here, to relate to the program as they go up the building. A quick overview in general terms, again, retail at the podium, office, hotel, condominium, and then observation deck at the top. We studied seismic shear wave and its impact on the tower, but what ultimately became the driving force behind what the forces on the tower were the Busan winds, which, as Chuck will mention here in a second, became some of the strongest forces on any super tall tower we've designed anywhere in the world.
What I mentioned. There were really two challenges for Busan Tower. As Brant mentioned, the wind, typhoon winds, 2 times the forces you would have in Incheon or in Seoul, which was a big factor in how we looked at this building. The other big factor was the aspect ratio. Because the tower was only about 58 meters to fit within this constrained site, the aspect ratio was about 7.2, so it was very slender. We needed a structure that had maximum stability throughout the structure to minimize the effects of the wind and motion perceptibility, but at the same time maximize the efficiency of the architecture and the views that Brant was speaking of from a triangular plan. What we chose was, I like to call, the organization of the structure is very similar to a tripod. Maximum stability. Moving 3 sets of reinforced concrete outrigger or mega columns out to the corners of the triangle, we're able to maximize the stability. We coupled this with a reinforced concrete core and tied them all together with structural steel outriggers strategically located, which I'll talk a little bit about in a couple seconds. The beautiful thing about this system is it's very clean and simple. It's an internal system, right? So it solved the issue of maximizing the views for all of the program stack, keeping the structure internal to the overall building. very similar to Burj Khalifa or other projects. Without the primary difference is it's a mixed-use program stack, unlike a residential unit. We play really close attention to keep the building simple. From a constructability standpoint, we maintained a vertical straight extrusion of the lateral system for ease of construction. As the building tapers up, rotates, the architecture rotates around the lateral system, which is totally concrete. The ease of construction of building that simple tripod with the vertical extrusion becomes cost effective. So based on this, the overall dynamic properties of the structure are quite good. We're at about 7 seconds for the first two translational modes, and a period of about, a torsional period of about 3 seconds. Of course, we, like all super tall towers, we analyzed and refined the building many times over with RWDI, looking at ways to take advantage of the concrete mass and the structural stability that we incorporated in the tower. In doing so, we had a very, very, very quiet building in terms of motion perceptibility. We went beyond what you would consider the international standards in terms of motion perceptibility. And we were able to meet AIJ 30 perception for 1 year with a 1 year peak acceleration of about 3.2 and 3.8, depending on which wind direction. That met the client's criteria to have AIJ 30 as the primary, more stringent criteria for this entire project, and we met that all the way up through the tower without any artificial dampening requirements. But the real interesting thing about this is how do we integrate the architecture to actually make this very simple tripod concrete system work for us even better? How can we use the gravity to manage the gravity loads to do even more for us? One thing that we decided to do was actually disconnect all of the perimeter columns for the program stack. By doing this, we could take all of the load and move them out to the corners, essentially eliminating all the tension from those very high wind loads that we had on the tower. In addition, by managing this gravity load, we could fine-tune the building, especially for long-term creep and shrinkage analysis. If we were able to manage the gravity loads, we could keep the stresses in the mega columns and the core relatively the same, minimizing the vertical differences between these over many periods. So over from gravity to shrinkage to creep, the stress levels between the core and the mega columns are essentially the same. But one of the biggest benefits of all of this was taking each of these program stacks and looking at them as purely a building located inside the tower. That gave us lots of advantages. We could change the column size, we could change the material, and we could change the lease span for each of the different programs that met their requirements. So for the office tower, we used a 6-meter grid at the base. Primary structural lateral system remains the same, and we could use a composite floor framing system and steel columns. As we go up, the first hotel stack, we could go to a 4.5-meter spacing because we disconnected each of the systems with a belt truss at each of the locations of the program stack. We could use concrete now on the upper floors, which is beneficial from lowering the floor to floor and allow us for all of the hotel and condos to use concrete. This allowed us to use flat slab systems on the upper portions of the tower. Similarly, as you go up for the condo, typical floors, lower and high, we could take advantage of the same system and reduce the overall column spacing and lease span as we move up the tower by rotating the tower in a reciprocal way. Another big advantage of this hardened area that we call the transfer floors is to take life safety issues into account. Not only do we have a concrete core, but we have places of refuge that are within the hardened zones of the mechanical areas and the transfer zones. But in the end, this building actually takes into account all of the different aspects of the program in terms of making the whole building work for you in terms of structure, managing the gravity loads, and taking a very simple approach in terms of the structural solution for this tower, which is going to create an iconic tower for Busan and a new gateway for Korea. Thanks.
Well, thank you for the all the programmatic and structural strategies. Thank you for the Busan. And this is the last presenters, so probably you guys are all hungry right now. But we'll take the questioners. So if you have any question, please raise your hands. No questions? All right, then William, you close out.
Okay, if there's no questions, then we're going to go ahead and close out this session. First of all, I'd like to thank all of our speakers for their presentations and for their time today. Peter, Mehdi, Jackie, Brant, and Charles. We really appreciate the effort that you put into this. Also, I'd like to thank all of you for attending this session. I hope you found it informative. And if you do have follow-up questions, all of our speakers are available, and they're nice guys, and you can talk to them during lunch or the next few days. So enjoy your brief lunch. We're a little bit behind schedule. And enjoy the rest of the program today and the next few days. Thank you very much.